So our final speaker is Kit. Kit is a research ecologist with the Wildfire Risk Management Science Team housed in the Human Dimension program at Rocky Mountain Research Station. His research is focused on integrating fire, insect disturbance, and changing climate into landscape planning and incident response. Kit is currently developing and testing a suite of analytical tools to facilitate strategic wildfire risk planning and incident decision support on landscapes throughout the Western U.S. Let's get the presenter role transition to Kit. Thanks for your help, Wes, and thanks for joining us, Kit.
Great, thank you, Diane. Let's see here. I've got.
I can see your screen.
All right. Now you're probably looking at the wrong one. Looking at my notes screen, is that correct?
I'm seeing notes. Yep. You go to display settings and hit swap.
Go.
Good to go.
All right. Okay. So first of all, thank you for giving me the opportunity to share some of the work that we have been rolling out over the last 3 years. And some of the stuff goes back much farther than that. And what I'm going to be talking about today is risk science. And none of this is foreign to anybody on this call. Operational risk is something that we manage for on fires every single day. That's what the Red Book is all about. It's all about looking at operational risk on a fire. What's our condition today? And it brings in all the other components of all the speakers that have talked today so far. It's kind of what is our snapshot of today of the risk that's out there. But what I'm going to touch on today is much more getting into that strategic planning side of things. So for that, we're actually taking a zoom out, and we're looking at our operating environment, not just today, but over the long haul. So if we're going to be managing a large fire, we want our decision making to reflect that. We want to make sure that our resource staffing, the weather conditions we can expect, all those things come in at this strategic level so that we make sure that we have the right resources in the right places when they can actually be effective, and ideally pull them out and have them stand down when they're not likely to be effective, and when we're just putting our firefighters at risk out there for very little gain. So with that, I'm going to move into kind of the objectives of this talk real quickly. The goal of this is to support safe and effective wildfire response. That's what all these tools are for. But these really tear directly off of what the chief has been talking about, of what does it look like when we have a safe and effective response, using some analytical tools to help inform decision making. A big part of this also is facilitating co-management of risk, both across spatial scales, so across, say, federal ownerships or private ownerships, but also looking across the command structure. So making sure that firefighters have a stake in the decisions that are being made, and then bringing that all the way up to incident command structure, and then into things like line officers, making sure that the people that are the decision makers and responsible for defending these decisions have a say in what these strategies are going to be. A big part of this also is expanding decision space. And so if we have all of the options laid out in front of us on the table, we can have a better chance to bring in the right decision making at the right time. And by having a lot of this stuff represented spatially, we can actually get into this pre-season engagement where we can bring partners to the table before there's ever smoke in the air. And we can start talking about realistic scenarios for wildfire risk as a fire is likely to progress, where are opportunities to act on that fire, and what kind of a response that our partners could expect, given a certain range of fire conditions. And then the last part of this also is providing some of these analytical tools at very short turnover times, so that some of these tools can be available to, say, an operations chief on an incident within 1 or 2 days of that incident getting going, and so they can start to use these immediately for short-term decision making as well. So what this looks like is this ideally we have a planning phase before we get that fire going, and that's often the case, but not always. But then some of these tools also help directly with execution. And then what a critical part of this is monitoring and understanding what the effects are of these components, and then getting some feedback so that we can improve these going forward. So what I'm going to touch on here is 3 analytical tools, one of which was defined in the start of this talk, which is the Quantitative Wildfire Risk Assessment. But the big goal of this is getting as much information at the fingertips of decision makers so that when they have to make that critical decision, they have everything they possibly can to go off of it. None of these analytics make decisions for anybody, but ideally they help inform those decisions a little bit better. So real quickly, what does that look like? 3 of the tools I'm going to talk about today are this Atlas of Potential Control Locations, Quantitative Wildfire Risk Assessment, and suppression difficulty. The Atlas of Potential Control Locations and quantitative wildfire risk assessment really are these strategic risk decision-making tools. And you can think of these working in more of that probability space. And so for that, think of something more like an FS Pro run, where you've got this range of possibilities, and you can start to hone in on what's most likely to happen under a certain time scale. So those first two tools are really designed for that. And then Suppression Difficulty Index is something that is much more kind of a quick snapshot of firefighter safety out there in the land. So I'm just going to touch on these real quick, and I'm going to get a little more in depth into the risk assessment. But this Atlas of Potential Control Locations, what we're trying to answer here is where on the landscape are fires most and least likely to be successfully contained. So if you have a varied landscape that looks like this is actually a shot from the North Cascades out in Washington State. We're trying to figure out what's the spatial representation of suitability for fire containment. So where are the areas where we're most likely to have a chance of success? And we base that off of landscape features that are out there and then a history of fire. And so what we do is we look at a 20 to 25-year history of fire on this landscape, and we actually develop a model to tell us how fires behave on this landscape, where they tend to get hung up, and where they tend to keep blowing on through. And so we have this index we come up with, which is this historical suppression effectiveness. Now, the critical part of this is historical. So if we're in a fire day or a fire condition that is out of the ordinary, if we have not seen these conditions in the 25 years that we're building this model off of, then this model is not going to perform very well. But if it is within that envelope, then it does provide some really useful information. The scaling and the color schemes that you're seeing here, those red zones, you see those typically are mid-slope locations where we have a very low probability of intercepting a fire and actually getting that fire to stop. We call those basically fire wicks. Those are places where a fire is likely to just keep on going. When you get into those cooler colors, though, those blue zones, we have a very high probability of that fire at least getting hung up, if not stopping. And if we can link together a lot of those locations, then we can actually potentially create a perimeter, or we can create a control location. Moving on to the next component, I'm going to talk about the wildfire risk assessment. So for that, what we're looking at is fire likelihood. First of all, we just model that using the large fire simulator. And what that actually gives us a sense of how likely any part of our landscape is going to burn. And we can run this at national scales. We can run this down to project scale. Ideally, in that planning phase, we're looking at larger landscapes, so say an entire national forest and all surrounding ownerships. Or this has also been run at state and broader scales at fine resolution as well. So we have a sense of the burn probability. And then once we know if something is likely to burn, we want to know how it's going to burn. And so given a range of fire history, historical fire weather, I should say, we can start to look at the distribution of flame length we can expect. If a place is going to burn, how is it likely to burn? So that gives us that intensity side of things. And then lastly, we want to know how that burn probability and intensity actually intersects with the things that we care about on a landscape. So for that, you can see here's just a stacked list of, say, 4 what we call highly valued resources and assets, the things that we're actively managing for on our landscape. And then on the right side, we have to come up with a response function. So basically, how is that thing we care about likely to respond to fire? I'll get into this a little bit more in the next slides. So what does this look like? Here's an example of the state of Montana. And just using the fire modeling components, we can look at what's the probability of fire occurring and what's the probability of that fire being an extreme event. So here what we can see is these red zones are areas where we have the fuels right and the weather tends to align with some pretty extreme fire conditions. The first thing you'll notice is that there are a number of cities that are in these areas that are likely to have these extreme fire conditions and a relatively high probability of ignition. Then you can overlay on top of that all of the things that land managers actually care about. So these are what we call those highly valued resources and assets. And now we start to see this intersection between the risk of fire and the things we actually are trying to actively manage for. So then we need to move into the realm of, okay, well, what does that mean when you have an intersection of fire and these other things? We generate this list of things we care about, the highly valued resources and assets, by having these workshops. This can be done at, say, a landscape scale, where you bring in multiple federal ownerships and private ownerships. You bring all the resource specialists together, and you develop these lists of things like, where's the human habitation? Where's the wildland urban interface? What's the infrastructure that's out there? We look at other values like rangelands, recreation, wildlife, watershed values, things like that. But we can also scale this up. So we can look at, say, Region 6. So at a regional scale, all of Oregon and Washington came together, and through a series of workshops, they developed a common operating picture of what are the values out there at risk and how are they likely to respond to fire. So for every value that you list in a workshop like this, you need to come up with a response function for that value. So we think about them kind of these three basic classes, but they can get much more complicated than that. Say it's a fire adapted resource, for example, would be like a fire adapted ecosystem. A fire susceptible asset. A fire susceptible asset could be something like a hardened infrastructure that could tolerate certain flame lengths of fire. You can probably see my pointer here. So for example, if we had a surface fire burning through here at our first flame length intensity, this is a tolerant object. Say it's a transmission line or maybe an oil derrick or something like that that can tolerate a certain amount of fire. But as that fire intensity goes up, the overall result of exposure to fire actually goes down. So we have more and more negative effects of that fire. And then we have things like wooden infrastructure, old cabins in the woods, wildland and urban interface. Those are areas that do not benefit from fire. Virtually any type of exposure to a fire is likely to cause a negative outcome from that fire. So that's what we're looking at here with a immediate negative response. For a fire adapted system, kind of going back to the first slide here, think of, say, a ponderosa pine forest where actually surface fire is likely to improve that value. You're actually getting a benefit to that system. So here we actually see a positive response to start with. It doesn't turn negative until you surpass a certain threshold. The other critical component of this is when you're working with land managers, they have to decide which of these values are most important. So here we're bringing in the ranking of landscape values and assets. We have that list of, say, 20 or 25 original assets, and then we need to figure out, well, which of these is number one for decision making, and which of these is less important. So for that, you can see here's just one example of, say, human habitation, wildlife, and urban interface. Human life is always our number one concern, right? So that comes up very highly ranked in this ranking system, but also water quality and ecosystem function come out as pretty highly ranked. So once we have all these components together, we can actually start to map this out. So given our modeled fire intensity and given those response functions, we can come up with our effects analysis. And given our fire probability, we can actually put all that out. And here you can see for the states of Oregon and state of Washington, this is the quantitative wildfire risk assessment. This can actually be used for decision making as you have a fire progressing across this landscape. What's the likelihood of there being a net benefit of that fire? Which is what you're seeing in these green zones, or a net negative outcome from fire, which is what we see in these kind of browns and orange colors. So if you were to dig into a much finer scale, you could actually start to see areas where you could see resource benefit fires, but you can also see areas where you have communities at risk. And so knowing this in advance allows you to start to make your planning dollars go to the right places and make sure we're getting an outcome that reduces that risk where it needs to be reduced, or actually make use of that positive outcome when you have that opportunity. So when you have a risk assessment product looks like this, we can also overlay that with some of the operational tools. So here I'm showing the Suppression Difficulty Index. This is basically how do firefighters size up a landscape. Here what we're looking at is the potential fire hazard. So what are the fuel types and weather conditions we can expect to basically cause harm to firefighters out there on the landscape, divided by our ability to mitigate that situation. So what are the mitigating actions? Things like road access, trail access, ability to cut fire line, a whole series of things that we can do to mitigate that fire hazard. We can then map that out on the landscape, and now we have an operational tool that basically points out those watch out situations if we want to act on things like the risk assessment or the potential control locations atlas. So how does this all fit together? We have the potential control locations atlas up here in panel A. That gives a really nice snapshot of where we're likely to have high probability of success in containing a fire. Then we work with fire managers on the ground to codify which of those are the best control locations. That's what's going on in B here. In C, we can overlay those best available control locations on top of that map of wildfire risk. Now we have these pods we've identified. These pods are potential wildfire operational delineations, basically a fire containment polygon that we can use to summarize that risk in a way that strategically makes sense in terms of wildfire response. And that's what you see here in D. In D, these green zones are areas where you have a net benefit of fire most of the time. So your immediate response or your default response is likely to be managing fire for resource use or resource benefit. As you get into these yellow and red zones, those are areas where you have concentrated risk, high susceptibility to fire, and those are areas where you probably need to focus more on keeping fires as small as possible, potentially a suppression response, or actually getting ahead of an ignition with doing some pre-treatment before you expose those areas to fire. What's nice about this framework is it allows us to get at planning across jurisdictions. Here's an example from the Santa Fe and Carson National Forest. The pod network is these yellow polygons. The green polygon you see inside here, the Santa Fe and Carson National Forest, and you notice those pod boundaries, these control opportunities extend well beyond the forest ownership. And the reason we were able to do that is because we didn't just concentrate on the forest. We brought in the Park Service, the BLM, the BIA, other ownerships to help us create this map and create a landscape scale understanding of how fire is likely to behave. Once you have a tool that looks like this, you can start to make it operational. We have a number of examples from the 2017, 2018, and 2019 fire seasons. We have one that's written up in Wildfire Magazine. But what this can look like on the ground is if you pull up WFDS, something that looks like this. This is that pod network from the Santa Fe and Carson National Forest. They've identified these specific control locations. And with these, they've also included the strategic response. So each pod is now assigned a risk profile. So we know that immediately when you get a start inside one of these polygons, you know what the risk is that's out there. And you have a sense of what the default response is likely to be to an incident. Now, understanding these default responses are not designed to constrain what you can do. If your conditions aren't appropriate for doing, say, a restore action, managing a wildfire for resource benefit, say you've got extreme fire weather, you have a resource shortage, you can always overrule these defaults. But the idea is to start to move away from a default suppression response all the time and really focus on when that is necessary and where that is necessary on the landscape. What this also does is it gives you a common operating picture. So here is an example of just south of Missoula. This is that atlas of potential control locations. These blue zones, areas have a very high probability of stopping a fire. These red zones, very low probability of stopping a fire. And unfortunately, in a landscape like this, what you see is this yellow line in here. That is the forest boundary. And as you see for the much of the Lolo National Forest, much of the Bitterroot National Forest, the forest boundary is not defensible. This is an area where you have a fewer than 10% chance of actually successfully containing fire historically. And that's very common, unfortunately, with a lot of federal ownerships. They're not designed to stop fire. They're designed to just show different ownership. And so this creates that common operating picture so you can have these discussions with the surrounding ownerships and talk about fire reality when it comes up. Real quickly, an idea of where this is being rolled out, so where you're likely to see these tools in action. Everything that's in green here is an area where we are actively engaged in the strategic wildfire risk management planning. We've now covered all of Region 3, all of Region 6. We are expanding out in Region 5 and Region 1. And we have kind of a hole in the middle here in Region 2, or in Region 4, I should say. But much of Colorado is also involved in this now as well. So you can see, and this is only current to 2019. We have been expanding out on this, so you can expect to see a lot more of these tools out there in the coming years. And for the 2020 fire season, these green areas are areas you can expect to have a lot of these tools already available at your fingertips. Also, these green zones, or these blue zones, I should say, are areas where we apply these tools in real time as part of risk management assistance. And so that's another one of these rollout opportunities to see these tools in action. And then I'm going to end with just some resources. I know you can't click on these on your own screen, but it did sound like Wes was going to be able to share these slides with you. So I will make sure that he gets a copy of this, and you can see some of these tools in action, like the Suppression Difficulty Index. We have that already worked up to the entire Western United States in an ARC map. And you can zoom into your local landscape and see what suppression difficulty looks like where you live. I also include a link to the Region 6 Quantitative Risk Assessment, the main homepage for risk management assistance products. That's something that we've been compiling since 2017. And then just for more information, you can go to the Wildfire Risk Management Science team homepage, and we have videos, we have links to talks, and links to additional resources. All right, well, that's what I have, and I think I am out of time.
Thank you, Kit, and thank you to all of our speakers today. Let's go ahead and get the presenter role transition back to me for a few minutes. As we wrap things up, let's go ahead and get to questions. You can raise your hand to ask a question, or you can type a question in the question chat box, and Wes and Tammy will be helping facilitate the questions. First question, Tammy, is that a question that you have asking about models? Did we get that one resolved? Okay, you might be muted. Oh, here we go. Questions coming in. Can you send all the links presented today in our emails? If it's for PowerPoint, I'm uncertain of that. Whatever attachments the presenters had for us, we can get those sent out, and we can contact you more about this after the webinar as well.
Yes, Diane. So the handouts that were given with Chuck McHugh's presentation on FlyMap 6 were emailed out. All of the presentations and a recording of the webinar will be posted on the AFELU website for NWCG, so you can get the presentations and the recording there.
Excellent. Thank you, Wes.
I do have a couple hands out. We can switch to there. I got Joel Curtis. I'm going to unmute you. Joel, did you have a question?
Yeah, can you hear me?
Yeah, I got you.
Okay, it was just a question about LAL. Yeah, I see easily why duplicate the effort. The only question that I would ask is, let's have a hard look at where we're going to express dry lightning. You know, where do we want that to come out in the messages for decision makers? That's my question.
Okay. Darren, are you still available to answer his question?
Yeah, and this is a big concern too, so it's not just your concern. We want to stress that dry lightning can be explicitly forecasted for already within the framework of the fire weather forecast. So we call it the sky weather section, basically the section of the forecast that says, you know, partly cloudy skies with a 30% chance of thunderstorms this afternoon. We could stress 30% chance of dry thunderstorms within that statement, or dry thunderstorms likely. And I think people seeing dry thunderstorms likely versus LAL of 6, I think seeing the words is much more meaningful and much more impactful. The one part we're struggling with this a little bit is trying to create plan view spatial maps that say those same things. So right now you could create a map that has contours of LAL on it. And, you know, maybe there would be an area of an LAL of 6 or dry thunderstorms on that map, but to try to create a map that displays both thunderstorm coverage and probability for dry lightning is kind of a different issue in of itself. And so we are working through that right now, and we're trying to come up with a reasonable way of displaying dry lightning information from a spatial standpoint.
Thank you.
Okay, it looks like another question is coming from Mike Haskin. Is there a proposed replacement for the Haynes Index?
All right, Brian, I unmuted you.
All right. So replacement in a loose sense. The Haynes Index includes stability, which actually, from a scientific perspective, is really weakly justified Stability near the ground is actually far stronger in terms of how we know it affects a fire's behavior. The instability up near where Haynes was looking is a kind of a stretch to argue. So no one has tried to rebuild the Haynes to include stability and everything. I hesitate to call it a replacement for the Haynes Index because I'm a co-author and co-developer on it, but it is the closest thing we've got now is the Hot, Dry, Windy Index. That's another whole webinar. The closest it comes to the above ground elements of the Haynes Index is that it looks at the lowest 500 meters and it evaluates the wind and the dryness of the air in that layer and takes the highest winds and the driest air to create the index.
And this is Larry. I'll extend upon that. One of the things when the Fire Weather Subcommittee proposed, what the future of Haynes Index and LAL was within wildfire community, some of the feedback we got is that there was exactly that. What are you going to replace it with? So we're part of that effort is what you're seeing today in terms of getting information out there and asking for feedback on it. But we're in the process of figuring that out right now. Is there a replacement, and if so, what would that look like?
Okay, thank you. We have a question hand up on the webinar from Colleen Haskell. Colleen, I unmuted you. Do you have a question?
I don't know if it's, yeah. So my question is to Darren, and he referred to some new tools and numerical weather prediction for lightning.
Colleen, we're having trouble hearing you. If you could scoot a little closer to the mic, maybe.
Is that better?
That is a little better.
Okay. Yeah, my question is for Darren Clabo, who referenced new numerical weather prediction tools for lightning flash density. And I'm wondering if he could send me as far as any literature or ongoing reviews that he has for those.
Colleen, I think we're having some mic issues on your end. You're kind of broken. Could you tap your question in the chat box, please? And if we can't get to it during this time, we'll make sure we follow up with you.
Okay, yeah.
Hey, this is Darren. Can you guys hear me?
Yep, we got you, Darren.
I think Colleen was asking more detailed question about where these lightning flash density forecasts and what models are running those. So I can just briefly address it. Some of the stuff that's coming out with the high resolution rapid refresh or the HER model, those will show some lightning flash density forecasts. Some of the other convection allowing models that are out there, some developments of the WRF also will show those. So you just really need a convection allowing model to get any kind of information specific information about thunderstorms. But right now, the kind of quasi-operational one that is out there is the HER, and you can get that information through NSEP.
Thanks, Darren. This is a question for Brian Potter. Is there a proposed replacement for the Haynes Index?
Should I repeat that?
No, we answered that. Okay. Question for Larry. LAL presentation from Rich McRae. Can the coverage of thunderstorm forecasts predict general wind intensity? The wind intensity may be more important than the number of strikes.
Well, Darren can chime in on this too, but I don't think, and maybe I'm misunderstanding the question, but the LAL never directly addressed wind issues at all. So I think those are two different things. I think the wind issue kind of goes more into what Brian was talking about with the hot, dry, windy index and looking into ways of making a better index than what Haynes is. But I think LAL or its replacement will focus specifically just on lightning strikes and lightning density.
Okay. Thanks, Larry. We had one more question. When will the NWCG Fire Behavior Pocket Guide become available, the replacement for Appendix B? We're hoping to have that out within a year or so. But I'm not seeing any more questions specifically in the question queue box. There was a couple comments in there. Are there any more hands raised?
We do have one more from Joel Curtis. We'll grab real quick. We are 1 minute behind, but we'll go ahead and, oh, Joel dropped off, so maybe not from Joel. Hold on.
One from Andy Harner.
Yeah, I see that. Andy, I just unmuted you. Did you have a question? Andy Harner, are you on? Or Hainer? Maybe not. I think that's going to be all the questions for now.
Very
if anybody
good.
has any, sorry about that. Go ahead, Diane.
Yeah, thank you for all the great questions. We've recorded today's webinar, and the recording will be hosted on the Advanced Fire Environment Learning Unit homepage. Thanks again for everyone's participation and for rolling through various little glitches we had with this webinar. Hope you all enjoyed it. If any additional questions are out there, you can email them to me and I will get them to the speakers. Thanks, everyone. Have a great day.
Thank you all.
Thank you.